Hi Year 11, in today's video I'm going to recap the product rule. I will be doing some questions from page 19 of your booklets, so please follow along. Let's begin with the first question, part A. We're given a function and we're not sure how to differentiate this without expanding first. But you know the product rule. And the reason why we use the product rule in this situation is because we see two brackets that are multiplied to each other. They're a product, right? And so we're going to use the product rule. We're going to label the first bracket as U, always, and the second bracket as V, usually always. We're going to write down our product rule, so dy dx, and if you can remember, it's the audio memorization tip I gave you a few lessons ago was VUV, like V-U-U-V, VUV, right? And the dashes are on the second letter. Okay, so VU plus UV, right, VUV, and then the dashes are here. Okay? So, of course, we actually need to figure out what UV U dash V dash R. So let's write that down. So U in this case is 3x plus 2. V is 2x squared minus 3x plus 4. And we don't know what U dash is and we don't know what V dash is for now, but we can actually find those quite easily. U dash we get by differentiating 3x plus 2. And when you differentiate 3x, we get 3. When you differentiate plus 2, you get nothing. When you differentiate, let's move on to V dash now. When you differentiate 2x squared, we get 4x. And then when you differentiate 3x, we get minus 3. And so now we have all the necessary information to use in the product rule. So I like to draw these little half circles to just remind me which pairs are being multiplied to each other. So the inner circle, U dash V, right, V U dash, so that's the first one. So we've got 2x squared minus 3x plus 4, that's what V is, times U dash, and U dash is 3, plus UV dash, so plus 3x plus 2, and then 4x minus 3. And you'll notice there that there aren't really any common factors. And so the only real way we can simplify this is probably by expanding. So let's expand everything. When I expand this bracket, I multiply everything by 3, and then expanding our quadratic over here, this will give us 12x squared minus 9x plus 8x minus 6. And if I collect all our like terms together, we will get 18x squared. We'll get minus 6x plus 9x, that's minus 15, and minus 15 plus 8. Ooh, I've made a mistake. That should not be minus 6, that should be minus 9. And so minus 9 gives us minus 18. Minus 18 plus 8 is minus 10x. And I've got a lone minus 6 somewhere. Plus 6, yep. Yeah, so I've got plus 12 minus 6, which gives us plus 6. Okay. So that is how we use the product rule to differentiate a function that is a product of two factors. Okay, let's also do part B together so that we can review the product rule. So we have x cubed plus 5x squared minus 3 x squared plus 1 to the power of 5. U, in this case, will be x cubed plus 5x squared minus 3. That's the first term. And our V will be the second term, or the second bracket. Let's differentiate our u. So when we differentiate u, we will get 3x squared plus 10x, and the minus 3 disappears. When we differentiate v, we drag down the power, so the power goes to the front. We write the bracket exactly the same. We minus 1 off the power, as usual, and then we differentiate the inside. When we differentiate the inside function, we'll get 2x. And then the plus 1, when we differentiate plus 1, it disappears. So we multiply by 2x. And then we get 10x, x squared plus 1 to the power of 4. So I've just moved that 2x to the front. Okay. Now let's actually substitute this into our product rule, right? So vuv, again, with the dashes on the second letter. And let's write down our first pair, which is u dash v, right? So we will get x squared plus 1 to the power of 5 times 3x squared plus 10x plus, and then our outer two factors, so these two. So we'll plus, and I'll write it down here since I don't have much space. And so now we have our product rule completed, and all we need to do now is simplify. Now, if you look at what we have here, this looks quite hard to expand. And you would be right in thinking that we do not expand, because expanding will actually make our life very, very hard. As you can see, we've got an x plus 1 to the power of 5 and then an x plus 1 to the power of 4. So we actually want to factorize as best as we can. And so let's look at our common factors. We've got a x squared plus 1 to the power of 5, and then we've got the same thing here, but it's to the power of 4. And then are there any other common factors? It looks like we've got an x squared and then an x, which means that we can probably factorize an x out. And so let's actually do that. So we can probably take an x out as well as an x squared plus 1 to the power of 4. And so let's think about, if we take this out of both terms, what will we get? So since it was a x squared plus 1 to the power of 5, there should be an x squared plus 1 left. And then, well, what else is left? We've already taken an x out of this bracket, and so what's left is just 3x plus 10. And then I've got plus, and I've taken the x out, I've taken the x squared plus 1 to the power of 4, so the 10 stays there, and I've got x cubed plus 5x squared minus 3. And so let's keep simplifying this really big bracket. We've got x squared plus 1 to the power of 4. Let's expand this bracket here. So we've got 3x cubed plus 10x squared plus 3x plus 10. And let's also expand this bracket. We've got 10x cubed plus 50x squared minus 30. And now all we need to do is collect our like terms. So let's look for all our x cubed terms. We've got this one here and this one here. And so that gives us 13x cubed. Let's look for all our x squared terms. We've got this one here and this one here. And so we've got plus 60x squared. And then let's look for our x terms. Well, there's just one here, and so that will give us plus 3x. And then our constant terms, plus 10 minus 30, that is minus 20. And let's double check that that is correct. And yes, indeed it is. Okay, so I hope that that was helpful. And please watch the next video on the quotient rule.